the rate constant rate of the reaction not only depends upon the temperature, it also depends upon another parameter called the activation energy. Therefore, combined this activation energy and the temperature dependency, Arrhenius derived an equation called the Arrhenius rate equation, which is given by the equation K is equal to A into e power minus Ga by RT. This is the equation that he has arrived at. What is K, what is A, what is EA, what is T, you all know this. And this, you know, called the fraction of the molecule crossing the threshold energy. The distribution of the energy in a molecule is like a Gaussian distribution. What is the maximum energy necessary for a molecule to undergo? Let us assume this is the energy required. We should undergo this one. And the molecules having energy in this part are said to be the active molecule. And these are all passive molecules. Why they are all called passive? They are not undergoing reaction, therefore they are said to be passive. And in order to make these molecules, passive molecules, to go to the active nature, we are infusing energy, transfer energy to that molecules by increasing the temperature. And how much energy is required, that we can also give in terms of a graph. This is the energy, average energy of the molecule A, and it is the maximum energy required for the molecule to undergo the reaction. This is the maximum energy. We call it as the threshold energy. The minimum energy required to carry out the reaction is called as the threshold energy. After attaining, and the molecules present in that threshold energy is also to be activated complex. We call it as activated complex. And then reaction is said to be taking place. And the products would be going, having energy lesser than the reactant. And we call this energy difference between the average energy and the threshold energy. We call this a passive molecule. The passive molecule to go for the active state. Therefore, it is called activation energy. We call it as activation energy. And it is given as EA. It is called as EA, activation energy. And the difference between this energy of the average energy of the reactant and the average energy of the products, we call it as the heat of reaction H. You all know this. And if you add a catalyst, the rate of the reaction is increased because the activation energy, that is energy required for the reaction, threshold energy is minimized. Therefore, the activation energy is minimized. Therefore, more number of molecules going to the active state, and we will get a rate of the reaction higher. These are all studied. Therefore, now the rate of the rate constant of the reaction depends upon two parameters, EA and temperature. These two are inverse to each other. What does that mean? Now you analyze this equation. You can give this one. And before seeing this, you will see what is EA power minus this one. This is nothing but the fraction of the molecule. Fraction of the molecule. Fraction of the molecule. Crossing the energy barrier, or fraction of the molecule which attains the threshold energy, or a fraction of the molecules which are ready for undergoing the reaction. That is called fraction of the molecule attaining the threshold energy. And what is A? A is called the free exponential factor. That is, it is a exponential parameter. And the factor present before this is called, we call it as a pre-exponential parameter or against parameter or specific rate constant. It's also called specific rate constant. Why it is called a specific rate constant? When will you use the word specific for unique property? Now, the amount present here equal to unity, as unit is unity. Therefore, A is now equal to the rate constant. Therefore, A is also called not a specific rate, but it is A by RT is equal to 0. Then also e power 0 equal to 1, and K is equal to A. Therefore, what is the condition? Actually, the rate constant would be attaining the maximum value. And what would be its value in that condition? The two conditions, then EA is equal to 0, and the temperature of the reaction is infinity. The rate constant would attain the maximum value of the A, that is homogeneous parameters. But practically, in practice, this is theoretically possible. In practice, for any reaction, EA is never be 0, and temperature infinity can never be achieved. Therefore, in practice, the K value would not be equal to A at all. And that's another thing. And the A is also, sometimes we call it as collision frequency. Collision frequency. And it is not, it should not be used in all cases. Only one particular order reaction, you can use the term A as the collision frequency. What is the order in which the A can be called as the collision frequency? Let us see. And what is the unit for A? Next question. Other part we can see on which order we can call it as a collision frequency. Unit for A. The unit for A is equal to the unit for K. Unit for K. Because whatever may be the unit present in the exponential factor, after taking exponential, this parameter is said to be having no unit at all. Which parameter is said to be having no unit? This parameter is said to be having no unit. Therefore, what is the unit for? What is the unit for A? The unit for A is equal to the unit for K. For a zero order reaction, A is having some other unit. For first order reaction, unit for this is A is equal to per second. For zero order reaction, the unit is mole per liter per second. For second order reaction, it is per mole liter per second and so on. Therefore, A is not having a constant unit. Depending upon the order, the unit for A is going on changing. And when will you call this A as a collision frequency? This one, when will you call it as a collision frequency? Collision frequency unit is so many times the collision occurring between the molecules, so many times per second. Or simply the collision frequency is having the unit per second. Therefore, when A is having per second unit, which will be occurring at first order kinetics. Therefore, for first order kinetics alone, you can call the A as collision frequency. For all other orders, you should not call it as a collision frequency. You simply call it as a linear parameter. And now we are going to see the other kind of equation. It is given in the exponential form. what is called Arrhenius rate equation is given in the exponential form. K is equal to A into e power EA by RT. When you take a natural logarithm on both sides, and you will get log K is equal to log A minus EA by RT. Taking the common logarithm, it would be becoming as log K is equal to log A, because you are multiplied by 2.3, and that we bring it into the denominator of this parameter 2.3 into RT. This is a log form. There is one more form, integrated form between the temperature T1 and T2, integrated form, that is given by ln K2 by K1, that is at two different temperature, equal to EA by R into 1 by T1 minus 1 by T2. This is an integrated form in the natural logarithm. In common logarithm, it is becoming log K2 by K1 equal to EA by 2.3 into 1 by T1 minus 1 by T2. These are the form. There is one more form, differential form. The differential form is d of log K by dt. That is differentiating this. Yeah.
So, this equation R in
sorry. Thank you very much. I have omitted. Sorry. Thank you. And differential form. We differentiate this, you would get a differential form of the d of log d log K by dt. It is a constant that is becoming 0. Here A is constant, R is the temperature is a variable. You will get EA by RT square. These are the various forms of the Arrhenius rate equation. In our problem, we are going to use this equation or this equation and this equation, because without calculator, we can make use of this one. And this equation is equal to this, the natural and the common. This equation is equivalent this and this. The differential form almost no problem if we ask. Therefore, you have to see this one and this one and this one. Now, before applying the problems in this, we will see the graphical representation, because at one time problem is asked with a graphical representation in 2 marks question. Graphical representation. First, we will represent the exponential form. Then we will represent the natural logarithm form. Then common logarithm form. In the representation in the exponential form, you know exponential function e power x, e power minus x. If you see this e power x, x value from minus infinity to plus infinity. If you apply this, the value is e power x value going on 0 to reaches a maximum. And the increase is tremendously increases initially. Therefore, we call it as an exponential increase. That increase is minus infinity. It's going on increasing like this. Or I will put the graph like this. Let us see plus x, this is a minus x. If you put this graph, it will be e power x. It's going slowly, it is 0 to going to this, and tremendously increases like this. This is the exponential increase. The exponential method, when x is equal to 0, that exponential curve will not pass through 0 because e power 0, a little bit later we have seen that the value is equal to 1. Therefore, the curve will pass through 1 unit, not through the arch. If you put the e power, if the increase is like this, we call it as an exponential increase. On the other way, for this e power minus x, what happened? From minus infinity to plus infinity. Put the x equal to minus infinity becomes plus e power infinity. The value is very high and it is going on decreasing. Once again, it is passing through this. When the x value is equal to infinity, it is going on approaching this one. Therefore, this is called the exponential decrease. This is called the exponential increase. And this is at unit 1, 0. Here, we are having the e power minus EA. Therefore, definitely as EA increases, the K value should be going on decreasing, exponential decrease. And which parameters we are plotting, that is very, very essential. Here, K is a constant. K is a variable as the T varies or EA varies. EA is a constant. The frequency factor is also temperature dependent. The frequency factor is also temperature dependent. But the change in the A value with the change in the temperature is found to be small. Therefore, in the Gaussian rate equation, we take A as a constant. Therefore, we usually tell that A is a constant. Therefore, EA and T. EA is a variable, T is a variable, K is a variable. According to EA, K would be going on changing. According to T, K is changing. How to plot this? Of these two variables in the exponential form, you should keep it in one as a constant. Then only you can plot the relationship between, and in one side the relationship is the K is taken in the y-axis and the temperature or either the EA as in the x-axis. K as EA. Or you can plot K versus T. K versus T. First, we will assume that temperature is constant. EA alone is variable. If e power minus E A by a constant, let us say a constant, okay, it is remaining as a constant. Now, the K value is depending upon, it is also a constant or it is proportional. Now, the K value depends upon the EA value. As EA increases, EA value increases, e power minus EA by value increases, and as we have already seen, as 0 at the EA value is equal to 0, it is e power 0, that is equal to 1 and therefore the value would be here. The value would be here. As EA value increases, e power minus value increases. E power minus value increases means the value decreases exponentially. And the graph would be like this. This is the graph I am obtained K versus EA. Now let us assume EA remains constant. The energy of activation is also slightly temperature dependent. For our calculation, we take it as a constant one, and which is changing. Now temperature is changing. what happened to the temperature? This is your constant. As T increases, the e power minus value decreases because it is in the denominator. As T increases, e power minus values decreases. E power minus value decreases means it's going on, value is going on increasing. For example, e power minus 20, e power minus 10, e power minus 1 of these three, which would be having higher value, this should be having higher value. Therefore, at e power 0, when the temperature is 0, it is 0 means K value is attaining here, it is not 0. And as the temperature is going on increasing, the value is going on this one, and you will find the value is going on increasing. This is K versus EA and K versus T. Therefore, this exponential plot you should have an idea. Then only if any question is asked, you can draw this one. Now we are going to see the graphical representation of this log K versus this variable with respect to 1 by T. If you take this log K is equal to Y, and ln A is a constant minus EA is a constant by R is a constant into 1 by T. Therefore, Y is equal to C minus M. 1 by T is taken as a X. Therefore, now it is in the form of a straight line, but with a negative slope and with the y-intercept the A. Therefore, this is a y-intercept. You will get a line like this with a negative slope, and the slope is equal to minus EA by R. If you take this problem is a log K, the same line would be obtained. Log K versus 1 by T. The one difference is in the natural logarithm of slope is equal to minus EA by R, but in the common logarithm it is minus EA by 2.3 R. This is the one thing. And using this, one problem has been already asked in the PHR examination. Can you take that one? Take that one in the 2013, I think so. According to Arrhenius equation, within brackets, K is rate constant and T is temperature. Option A, ln K decreases linearly with 1 by T. Option B, ln K decreases linearly with T. Option C, ln K increases linearly with 1 by T. D, ln K increases linearly with T. Which is the correct option? Tell me the correct option. ln K
increases linearly with T.
Increases linearly with T. Is it correct?
Decreases linearly with T. 1 by T.
Yeah, decreases linearly with 1 by T. That's the correct answer. 1 by T answer is just reverse our workout 24. The another question in the 2015, which of the following plots represents bracketக்குள்ள yes போடுங்க represent or bracketக்குள்ள yes the Arrhenius rate equation. the Arrhenius rate equation. K is equal to A into E power minus EA by RT with A is equal to 3 into 10 power 7 per second. And EA is equal to 3 into 10 power 4 joule per mole. Remember, draw the diagrams given. Option A, 1, option B, 2, option C, 3, option D, 1 and 2. What is the correct answer? So, what is your opinion? What is your opinion? 1 and 2 is the correct answer. That is the option D is the correct one. Just now we have plotted this. It is asked in this direction. Okay, graphical representation is over. Now we are going to work out the problems using the formula given. Take down the first problem, and if you are able to work out, if you understand the equations, take down the first two problems. For your first order reaction, the rate constant at 500 degree Kelvin is 8 into 10 power 4 per second. 10 power 4 per second. Calculate the frequency factor. Calculate the frequency factor. If the energy of the activation of the reaction is 190 kilojoule per mole. 190 kilojoule per mole. And what is given? Calculate the frequency factor. A is asked. Okay. You know Arrhenius rate equation K into A into E power minus EA by RT. We will take this equation first. Then we will apply which equation is very easier for our calculation. Which is given the first order rate constant, this is given. Which is asked the active frequency factor, this is asked. And EA is given, this is given. And next one, the temperature is also given. Or the gas constant you should substitute. Here A is called, keeping it in the exponential form, we will find it somewhat difficult. Therefore, go for the logarithmic form. Which logarithmic form? Natural logarithmic form or common logarithm? Common logarithm form is very easier for us. Now take the common logarithmic equation. Log K is equal to log A minus EA by 2.3 RT. Not 2.3 by RT, EA by 2.3 RT. Now substitute the equation, parameters, substitute, and here you should be very cautious. EA is given in kilojoule, therefore either you should, and R should be either in kilojoules, or you should convert the EA into joule and R in joule. That is a very important step here. Instead, a very easy way to doing is, if it is EA is given in kilojoules, keep it as in the kilojoule by 2.3 into, instead R 8.3 into, make it into kilojoules by multiply it with 10 power minus 3, it is giving the kilojoules by 1 by 500. Log K, K is equal to log of 8 into 10 power 4. What is log of 8 into 10 power 4? You know this 8 to the 0.9 is equal to 4.9 is equal to log A. And apply your calculator to work out this value. Apply your calculator simplification method we have already taught to you. And that is found to be nearly 20. Nearly 20. Therefore, what is log A? Log A is equal to 24.9. What is A? Anti-log of 24.9. 0.9 here to, I'm sorry. Sorry, 24.9. Okay. Log of anti-log of 24.9 into 10 power 24.9 already have taken as a A. Therefore, A is equal to 8 into 10 power 4. It is a simple problem given under Archimedes one. Now I will give you one more problem, and all other problems would be based upon this one. It's a very, very easier thing. So if you properly understand it, take down the next question. Rate constant K of your reaction varies with the temperature according to the following equation. According to the following equation. Log K is equal to log A minus EA by 2.3 R into 1 by T. Where EA is the activation energy. First, when a graph is plotted for, when a graph is plotted for log K versus 1 by T, log K versus 1 by T, a straight line with a slope of, minus 4,000 Kelvin is of time. Calculate the activation energy. Calculate the activation energy. How to approach this problem? I have already given the formula, the highlighted formula. They have plotted the log K versus 1 by T. Therefore, what is the slope of this? Looking at the equation, you can say me the slope of the equation, straight line. The slope of the straight line is equal to minus EA by 2.3 into R. This is the slope of the straight line equal to minus 4,000. Therefore, what is EA? Put EA minus and minus cancel. EA is equal to 2.3 into R 8.3 into 4,000. So many joules per mole. And whether the answer is given in the joule per mole or kilojoule per mole, accordingly you change the one. Okay. And I will give you another type of problem. We have given three types of equation. One is a k exponential form, then logarithmic form. Then the logarithmic form we give two equations, common logarithm and natural logarithm. And then finally the integrated form, the two different temperatures k values are given. It is also given. And now I am going to give the problem in the integrated form in two different temperatures. Take down the question. The rate constant of a reaction. The rate constant of a reaction at 400 degree Kelvin and 200 degree Kelvin. 200 degree Kelvin are 0.04 and 0.02 per second respectively. Per second respectively. Calculate the value of activation energy. Calculate the value of activation energy. Here, K values are given at two different temperatures. Therefore, you should apply the integral form of the Arrhenius because energy of activation is given, K values are given. Immediately seeing the K values and the energy of activation, you should go for the Arrhenius rate equation. In the Arrhenius rate equation, which form should be taken? Which is the exponential form, or the logarithmic form, or the integrated form at two different temperatures? You should take it at two different temperatures. Therefore, the formula to be used is log of K2 by, write down that formula. Here my style pen is talking out. Log of K2 by K1 is equal to EA by 2.3 R into 1 by bracket, within bracket, 1 by T1 minus 1 by T2. Now substitute the values given in the problem. Substitute the values given in the problem. Substitute the now you are getting log of 0.04 by 0.02 is equal to EA by 2.3 into 8.3 into 1 by T1 200 minus 1 by 400 T2. And if you this cancel, you will get to log 2 is equal to 0.3, and you can find out the value for the EA as EA is equal to, bring all the terms in the other side, you will get like 0.3 into 2.3 into 8.3. If you put the value R in the 8.3 joule, the EA would be obtaining in the joule only. Otherwise, you can go for the kilojoules. You should multiply it with the 10 power minus 3 into. Here, how to write down this? This and this would be coming in the uppercase 200 into 400 divided by the difference between them 200. This is the value. You just multiply it and this cancel. And 10 power minus 3 here 2 and use your calculator. Find out the answer. Just rearrange them. I think how this is equivalent to this. You understand this concept. How I have. Otherwise, you multiply here itself, then bringing it to the opposite side. Okay. Another problem, take on the next type of problem using the exponential factor itself. Using the exponential factor. Otherwise, how to work out that problem. Take down the problem. A catalyst lowers the activation energy of a reaction from 20 kilojoule to 10 kilojoule per mole. 20 kilojoule to 10 kilojoule per mole. The temperature at which the uncatalyzed reaction will have the same rate, as that of the catalyzed reaction, at 27 degrees centigrade. At 27 degrees centigrade is option A, minus 123 degrees centigrade, B, 373 degrees centigrade, C, 327 degrees centigrade, D, 23 degrees centigrade. Here, how to approach this problem? You can make use of our exponential form. This is the equation. Here, you should make use of this equation 2 times. One for the catalyzed reaction, another for the uncatalyzed reaction. Let us Ku. What is U? Uncatalyzed reaction. It will be A. And uncatalyzed reaction, the energy of activation is from 20 kilojoules they have given, therefore minus 25. Or temperature, N and B, and they ask the temperature achieved the uncatalyzed reaction will have the same rate as that of the catalyzed reaction at 27. Therefore, the temperature we have to calculate, therefore put it as T. Then you should apply the same equation for a catalyzed one. Let us assume for catalyst AC. AC is equal to the collision frequency into E power. For a catalyst reaction, the energy of activation is given to be 10 by R into, sir, why can't you put the value R? Because it is going to be cancelled. Therefore, I have not given the answer. Temperature. What is the temperature? At 27 degree Kelvin, therefore 300. This is the data given for the catalytic reaction. They say that what is the temperature at which there is uncatalyzed reaction rate will have the same rate of a catalyst. That is, Ku is equal to Kc at what temperature? At what temperature? If these two are equal, the parameters present in the right hand side should also be equal. Therefore, now your equation is changed to minus 20 by RT is equal to e power minus n by 300 R. This e power, therefore minus 20 by RT is equal to minus n by 300 R. This R and this R cancel. Now find out what is T. You can easily find out that T is equal to this minus and minus cancel. T is equal to 20 into 40 300 by 10 equal to 600. Equal to 600. But here it is given as a degree centigrade. Therefore, convert the degree Kelvin into centigrade. You will have the answer. Now we will give another different, but within the same formula, but a different approach is given. Take down this one. The rate constant for a second order decomposition of A to B. A to B. A to B is given as, take down this, K is equal to 2 into 10 power 10 liter per mole per second into e power minus e power minus 3 into 10 power 4 degree Kelvin by T. What is EA? What is EA? In, within bracket, in kilojoule per mole. Kilojoule per mole. Bracket close for the reaction. Take down the option A, 150 kilojoule. B option 200. C option 250. D option 300 kilojoule per mole. And very, very simple is this one. Here it is given in the exponential form. You know the exponential form of this equation as K is equal to A into e power EA by RE. This K and this K equal. This A is equal to this value and EA by value is equal to this one. Therefore, now you are having the equation. EA minus EA by RT is equal to minus 3 into 10 power 4 by T. You are asked to calculate, calculate பண்ணணும்னு சொல்லியிருக்காங்க. This T and this T cancel. You are asked to calculate EA minus and minus cancel. Therefore, EA is equal to 3 into 10 power 4 into R. R it is given in kilojoule per mole. Therefore, joule means R value is equal to 8.3 into 8.316 joule. Convert into kilo means 10 power minus 3. Sometimes you may be asked to give in kilocalories, according kilocalories. If calories are given, R value is equal to 1.987, or you can simply put it 2, kilo means 2 into 10 power minus 3. You will definitely get this and multiply. What is the correct answer? Tell me the answer. Tell me the answer. And now you have to calculate only the EA. The EA, now you can find out the answer for this one, EA. What's the correct answer? Multiply it. 250, therefore this is the correct answer. But if you look at the problem, it is found to be a difficult one. If you understand this during your reading itself, oh, this is the formula, I have to take it and substitute for solving this problem. You can easily understand this one. There's another type of problem I will give you. Take down this. The rate constant of a reaction at 27 degrees centigrade. At 27 degrees centigrade is 2.3 into 10 power minus 3 per minute. And at this temperature, point not one 0.01% molecule of reactant molecules is able to cross the energy barrier existing between reactants and products. What can the maximum value of the rate constant? What can the maximum value of rate constant be achieved on raising the temperature? What can be the collision frequency? What can be the collision frequency of the reaction at this temperature? The collision frequency at this temperature. How to work out for this? This can be worked out whether it can be using the exponential equation or this equation or logarithmic form or whatever may be done. For me, it is found to be easier to work out using the exponential form. Why it is easier? From the beginning, at the beginning of this discussion, I told you that what is this indicate? Tell me anybody. E power minus E by RT represents what? என்னன்னு சொல்லியிருக்கோம்?
Fraction of molecules crossing the energy barrier.
இங்க என்ன கொடுத்திருக்காங்க பாருங்க. At this temperature, 0.001% of the reactant molecule is able to cross the energy barrier. But they have given this percentage for this, the E power, this value is 0.001 divided by 100. Why you are putting 100? We have told you that it is a fraction. Fraction for 1 unit. But here it is given as percentage. What do you mean by percentage? Anybody tell me? So many percentage is equal to how many fraction? Yara solla mudiyuma? Seri. If I will tell you 0.001 percentage. What do you mean by this? 0.001 divided by percentage 100. This is equivalent to the fraction. This is not the fraction. This is the fraction of the molecule. Therefore, that's a small now in that place. Be careful. The value of K is 2.3 into 10 power minus 3 equivalent to A into 0.001. Some students may work out it using this alone, and for them also the answer would be readily available in this bracket. But you have to put 100. You should convert in the fraction. You should not be in percentage. That is negative. That made the difference between the shrewd students and the dull students. Therefore, you should be in fraction, not in percentage. If percentage is given, you should divide it in 100, and from which you can calculate what is the value of the A. And I have given one already. I have given one question. What can the maximum value of the rate constant be achieved on raising the temperature? That A is equal to 200 and what is the answer you obtain? 230 per minute. I think so. Is not. How you have arrived at that? This and this multiply this. You can easily tell what is the value? 230 per minute. What is the answer? And what is the maximum value of K that can be obtained? What is the maximum value of A that can be obtained? The maximum value of K obtained is equal to A. At the beginning of the lecture, I have told you K would be equal to A. But what two conditions? What are the two conditions? EA is equal to 0 and P is increasing. The question asked is, what can the maximum value of rate constant be achieved on raising the temperature? Temperature raise one. The maximum value that can be obtained by the K value is 230. That's the maximum value. Beyond 30, no value is obtained. Next, I will give you another type of problem in the exponential form itself. It is asked in the year 2010, I think so. Take down the question. The specific rate constant, you know what is the specific rate constant? The specific rate constant of decomposition of a compound. Decomposition of a compound is represented by log K is equal to 5 minus 12,000 by T. The activation energy of the decomposition of this compound at 300 degree Kelvin is option A 24 kilocalorie per mole. Option B, 12 kilocalories per mole. Option C, 24 calorie per mole. Option D, 12 calorie per mole. How to work out this problem? K is not given, but log K is equal to 5 minus this one. And what is the equation to be used for this? They have already given the equations. Why can't we go for another equation? No, you have to correlate the general equation in the natural logarithmic form. What is a natural logarithmic form? We are using log A is equal to log of A minus EA by RT. This is the, am I correct? EA by RT or EA by 2.3 RT, which is correct?
EA by RT.
This is EA by RT. Why EA by RT is correct? Because it is given in the natural logarithm. It is in the common logarithm, it will be EA by RT. Now correlate this general equation with the given equation. Now you understand the problem, whether you are able to find out the answer for it or not. It can be easily done. From which you can also able to calculate what is the value of A. That is log of A is equal to 5. Then what is the A value? You convert this, if it is asked, convert into log of A equal to 5. And log A is equal to divided by 2.3. And then for A, find out the anti-log. Okay. But our problem is, they are calculating the energy of activation. This part is taken. And this part, now correlate this one. EA by RT is equal to, EA by RT is equal to 12,000. Temperature is given. Here T and T can be cancelled, and EA is equal to 12,000 into R should be here, calories is given, not in a simple one, 2. If you put this in calorie, you will get the calories. Instead, kilocalories, 10 power 3. And you work out it, and what is the answer? Option J is the correct one. They are also giving the option 24 calories. The unit-wise, the students may be struggling. For them also, this is given. But if you read the problem, it is going to be tedious. But you compare with something, it's going to be very, very easier. And like give 2 more problems are here there in this activation problem. Then the remaining problems you can go and work out yourself and take down the problem. EA for your reaction, EA for your reaction is 4.18 kilojoule per mole. 4.18 kilojoule per mole. A is equal to 5 into 10 power 10 AM cube per mole per second at 300 degree Kelvin. At what temperature? At what temperature? The rate constant would be twice that at 300 degree Kelvin. Twice that at 300 degree Kelvin. 300 degree Kelvin. Option A, approximately 500 degree Kelvin. B, approximately 400 degree Kelvin. C, approximately 600 degree Kelvin. D, approximately 650 degree Kelvin. Also correct answer. Here, read the problem. And what is the formula to be used? You are right here. Energy of activation is given. Therefore, definitely the equation is based upon
Arrhenius equation.
Arrhenius equation. In the Arrhenius equation, we are having three different forms. Which form it is you are able to complete this problem, or which once again the integral form. What is the integral form? Because rate constant at one temperature is at what temperature the rate constant would be twice at 300 degree Kelvin. One temperature is given, and what would be the rate constant at the another temperature? Therefore, you should make use of two different temperatures. That is the integral form. That is the form of integral formula. என்ன எழுதுவீங்க? Law. சொல்லுங்க. Law.
Q2 by K1.
And K2 by K1 is equal to. Write down the formula. K2 by K1 is equal to EA by 2.3 R within bracket 1 by T1 minus 1 by T2.
Excuse me, sir.
Yeah.
Sir, நீங்க அப்பமா ஒரு இது சொல்லும்போது ட்வைஸ் பண்ணுவோம் 10 டிகிரி இன்க்ரீஸ் பண்ணானா ட்வைஸ் ஆகும் அதுவா டபுள் ஆகும்னு சொன்னீங்க சார். அதை பேஸ் பண்ணி போடக்கூடாதா சார்?
அதை பேஸ் பண்ணி அந்த டெம்பரேச்சரை 10 டிகிரி ரைஸ் பண்ணா போதும் அப்படின்னு நீங்க சொல்றீங்க. Here, energy of activation is also involved. You should take into account. If no energy of activation is given, you can go by our previous discussion. That is, the rate of at a higher temperature should be equal to rate V. அதை வச்சு நீங்க போடலாம் ட்வைஸ் அப்படின்னு போட்டிருக்கலாம். அதுக்கு you should be given என்ன கொடுத்துருக்கணும்? The temperature coefficient of the reaction should be given. But here temperature coefficient is not given. Instead, EA is given. Therefore, you should go by the and this equation, Arrhenius equation. Okay.
Okay.
Then substitute K2 by K1 should be twice. It should be twice. Therefore, 2 is equal to log 2 is equal to substitute the EA value as such 4.18. 4.18 and log 2 is equal to 4.18. Here you are substituting as a kilojoule. Therefore, at the bottom of this R should also be in the kilojoules, for which we are writing is 8.3 into 10 power 3 into 1 by T1 lower temperature, that is nothing but 1 by 300 minus 1 by T2, that is the temperature they are asking. Log 2 is equal to 0.3 equal to 4.18. We will simplify in the next step. 2.3 into 8.3 into 10 power minus 3. Or leaving this, you can bring the all other things in the opposite side. Or you wait and see here. You write it as 300 T2, that is equal to that is an easy way. Without this, Bring all other things in the opposites. That will be easier for your calculation. 0.3 into 2.3 into 8.3 into 10 power minus 3 divided by 4.2. Why you are using 4.2? You know this. That is equal to 1 by 300 minus 1 by 2. Okay, this is the one. Now find out the value for this. How much is this one? Value எவ்வளவுன்னு சொல்லுங்க பார்க்கலாம். இதுக்கு எவ்வளவு வருதுப்பா? Anybody?
1.27 into 10 raised to minus 3.
எவ்வளவுமா?
1.37 into 10 raised to minus 3.
9.4 into 10 power minus 3, yeah?
1.37.
1.37, okay. 1.4 into 10 power minus 3, am I correct? I have correctly written. These are 4.2, these approximately 2. 2 into, what's wrong is given, 2 into 4, 3, 4.6. 4.6 into 0.3, 8, 1.38. Okay, 1.4 into 10 power minus 3. Okay, thank you. Is equal to 1 by 300 minus 1 by T2. Or it can be written as 300 T2 into T2 minus 300. Now bring this in the opposite side. 1.4 into 10 power minus 3 into 300. T2 is equal to T2 minus 300. Find the value of T2, from which you can easily find out what is the value of the answer. Find out the answer. Nobody else is there.
Option A, sir.
Option A is correct answer. You are correct. Next, we will go the last but one problem. There's last problem I will give you. The next one is the homework for you. The last problem is asked in the year 2012. Take down the problem. For a reaction, the rate constant K at 27 degrees centigrade. The rate constant K at 27 degrees centigrade was found to be K is equal to 5.4 into 10 power 11 into e power minus 50. The activation energy of the reaction, bracket in joule per mole, not the point, in joule per mole, bracket close, is option A, 50, B, 450, C, 15,000, D, 1,25,000 joule per mole. Find out how to approach this problem. Here once again, here are the activation energy. Therefore, the problem is concerned with Arrhenius rate equation. Arrhenius rate equation is in three forms. Which form I have to make use of this? You read this and you find out which form should be applicable. Which form is applicable to you?
Exponential form.
Which form?
Exponential form.
The exponential form. Compare this exponential form. Whether it is easy for you to calculate the energy of activation or not. Is it possible or not?
Yes, sir. Option B.
Yeah. Option
B, sir. 1,25,000.
1,25,000. Since your answer is correct, that is one. Here now you compare. What is the value of A? Value of A is equal to 5.4 10 power 11. And what is the energy of activation? That is given by EA by RT is equal to 50. And what is the temperature given? 27. Therefore, EA is equal to 50 into 300, the 27 degree Kelvin centigrade is converted into this. And R should be in Joule. Why it should be Joule? Because answer is given in Joule. Therefore, this will multiply it, you will get the answer. A problem to be exercised in your home. Take down the problem. A first order gaseous reaction. It is asked in the year 2013. A first order gaseous reaction is 25% complete in 30 minutes. In 30 minutes at 227 degrees centigrade. And in 10 minutes at 237 degrees centigrade. The activation energy of the reaction is closest to 2. The activation energy of the reaction is closest to 2. Within bracket, R is equal to 2 calorie per degree Kelvin per mole. Option A, 27 kilocalorie per mole. Option B, 110 kilocalories per mole. Option C, 55 kilocalories per mole. Option D, 11.8 kilocalories per mole. Here, what is the equation to be used once again? Activation energy is R. Therefore, you should have which type of equation? Arrhenius rate equation. In the Arrhenius rate equation, which type of equation should be used? We have two different temperature is given, and therefore you should go forward after the integral form. Log of K2 by K1 is equal to EA by 2.3 by RT into 1 by T. Here, K1 and K2 are not given at all. What do you have to calculate? They are given the first order gaseous reaction is 20% complete in 30 minutes. It's a first order. For first order kinetics, you know the equation K is equal to 2.3 into log of initial concentration by the terminal concentration at the time t. that is amount of layer. The K1, that is temperature at 227 degree, 2.3 by T, this is 227 degree, 30 minutes is required. And the percentage is given, therefore, you can put this as 100% in here. And the gas area completed is 25%. Therefore, left is 75%. This is K1. Similarly, you should work out for K2. K2 is the rate function at another temperature, for which 10 minutes is taken for the same 25% completion. Therefore, equal to 100 by 75. Now you can arrive at the value of K2 by K1 from the equation. Knowing the value of K2 by K1, you substitute in our integral form. And the integral form, the only unknown is the energy of activation. You can calculate. You have already given in our previous questions. Therefore, it will be used. It will be easier for you, I think so. Okay. With this, I have finished the Arrhenius ready equation and the possible problems. And for some more problems, you go across the question papers. So far appeared in the CATE as well as CSAR and DIFR and so on. You work out and doing exercise on this, you will easily understand the village problem. Okay, with this I finish my lecture for today's lecture.